Hello, Joel.
Yes, ma'am.
When record starts, then I think so we will not be able to make anyone in. Or it is okay.
No, ma'am, they can join still.
Okay, okay, ठीक है.
Is my screen visible?
Yes.
Yes, yes, yes.
Yes.
Okay, okay. So, greetings to one and all. As you know, I am Joel Silas, studying in the second year of the computer department at JSPM's JSCOE. I extend a warm welcome to one and all for this first day, first session on the course of C programming. So, I have received a lot of positive and encouraging feedback given by you people. Thank you for that. So before we start, I will give some instructions that I'll be starting from the beginning. So even if you don't know programming, you can attend this course. And seeing how fast you can grasp or understand the concepts, I will decide at what speed I should deliver my content. And you can take down notes in between if you want. And in between, I may ask anyone to answer the questions that I ask. Either you can unmute yourself or you can type it in the chat box. So the session will be interactive. And as you know,
Okay.
at the end, we will have one quiz. And today, your performance in the quiz will contribute to what score you gain each day. And by the end of the course, you may gain some prize if you are the highest. So, and in today's session, I'm also going to tell you which software or mobile app or Android app you can use for the programming. So, for C as well as C++ programming, if you do C++ programming in future, you can use the same software. The first is for the mobile phones or Android phones. The first one is C4 Droid. It is a paid one, but there is another one which is free, that is CPP Droid. So both are good, but I suggest you go for the free one. And for laptop or desktop or for your PC, you can use Dev C++ IDE. Now, why I'm suggesting an IDE, that is Integrated Development Environment, because IDE is a software where you can design or develop your program or your code very easily. So it comes with a compiler and editor. It may give you certain suggestions that if you're making any mistake, you may get an error even before your program is compiled. Then it may highlight if your curly braces are not given properly, if there is any syntactical error. So it is good for learning a programming language at a beginner level. So if you install Dev C++, it will be good for you to learn. And also, when you come to the second year, especially those who are from the computer department, initially they will be working on Dev
Your
C++
voice is not
IDE.
clear.
It's clear.
Yeah, it's clear.
Yeah, it's clear.
Okay, okay, yeah. So to install Dev C++, what you can do is, I will provide one YouTube video link after this session, and from there you can see and install it. If you have any problem, you can ask me. So uh, you can either go for CPP Droid on mobiles or Dev C++ for your laptop, PC, or desktop. So the agenda for today's discussion is Unit 1, that is Introduction to C language. What we will be learning is the need of programming, types of software, basically system and application software, introduction to programming languages, paradigms, need of compilers, interpreters, application of programming languages, some basic brief history, then benefits of C language over other languages, what is algorithm, flowchart, and pseudocode, and the basic structure of a program. So today's session is basically theoretical, but from the next session onwards, it will be more practical. So this is the first topic, what is programming? We have seen this on Sunday as well. So I'll quickly go through these points. Programming is the process of creating a set of instructions which tells the computer how to perform a task so that we can find a particular solution to a certain problem. So in order to solve the real-time problems, we can develop different programs. Program can also be defined as a notation of algorithms and data structures. A program consists of algorithms and data structures. Now, programming can be done in different programming languages, such as C, C++, Java, JavaScript, Python, Kotlin, R, and so on. Now, why do we need to learn so many programming languages is because the programming languages are domain specific. Now, what do you mean by that is, for a particular domain, you need a particular programming language. For example, if you want to learn Android development, it is usually done using Java or Kotlin language. If you want to do machine learning, usually you use Python or R language. So according to the requirement of the domain, you have to use a particular language to suit the requirements of your program. This is just the introduction. Now, programming languages can enable us to write efficient programs and develop real-time solutions for the problems. Now, programming can be used to automate, maintain, assemble, and interpret the processing of data and information. It helps us accelerate the applications so that our life can get easier and faster. So there can be rapid progress. Now, next is a brief history of programming languages. Now, this is, you don't need to remember it, but just for your information, I'm giving you. It began in 1951 to 1955. There was experimental use of expression compilers. Then you had certain basic programming languages like Fortran, COBOL, Lisp, Algol 60, which were developed from 56 to 60. Then you had some evolution. You had better programming logic, features, constructs, and all in your programs. And year by year, after a span of 4-5 years, different programs were developed. I'll be sharing this PPT. You can go through this later. Then finally, in the year 1971 to 75, C language, you can see here, C language was developed. Then after a couple of years, between 86 to 90, C++ came into picture. Then from 96 to 2000, Java came. And then finally, 2000, quite recent, C#, Python, Ruby, Scala, all these languages came. Now, I just want to tell you that C# or C hash, this one, has the drag and drop feature. Means sometimes you will not have to write the code, just you can drag the elements onto your workspace and automatically the code will be written for you. So it's quite an advanced feature which can help you develop your software rapidly. Now, why do you need to study programming languages? I've already told you. So here, just some basic points. Why? To improve your ability to develop effective algorithms. If you study a programming language, you can develop the efficient and effective algorithms. One of a characteristic of algorithm is it should be effective. You have studied it in Python Unit 1. Now, to improve your use of existing programming languages, you can learn different programming languages. To increase your vocabulary of the programming features or constructs, you can implement these languages and learn them. Now, to allow a better choice of programming languages, I told you there are domain specific. Different domains require different languages. So you can make a better choice of which language. For example, for Android development, recently Google has declared Kotlin to be its official language instead of Java. So there's a better choice. Though you can program in Java, Kotlin is a better choice. That is just an example. Now, it can make it easier to learn a new language. If you learn one language, you can learn another language very easily because same things, you have to just change the syntax and imply. It can make it easier to learn a new language, and you can design your own language also in future. Now, why should we learn C programming? Because it is a must for students and working professionals to become great software engineers, developers, graphics, and also it can be used in interdisciplinary projects. Interdisciplinary means various domains like mechanical, computer, IT, electronics, electrical, civil, all these domains, their characteristics can be combined together and they can be enabled to work together to serve the purpose. So you might have heard of IoT, Internet of Things, and all these concepts can be combined to obtain a very efficient solution. Now, why to learn C programming? Because of its key advantages. It is a middle level language between low and high level. That is, it is a structured language. It has a particular structure, a design, simple set of keywords. I have told you keywords means they have predefined meaning. You cannot use them anywhere in your program. They should implement their meaning. Now it produces efficient programs and faster computations. low level activities you can perform. It helps us understand the underlying architecture, that how internally the things are working, you can easily understand using C language. So when you're learning other languages, it won't be a problem. It is a compiled language. It can work on different platforms, means cross-platform. Means it can work also on different operating systems like Windows, Linux, and so on. It helps you learn modern languages, concepts like pointers, memory locations, you can easily understand. It is a popular system programming language, and it is widely used by software developers. Now, why we are studying this? Because it has certain applications and we should know the applications. Otherwise, there's no point in learning the theory behind it. Practicals are the implementation of the theoretical concepts. So some of the applications are operating systems, language compilers, assemblers. We will discuss what is assembler in the upcoming slide. Then text editors like Notepad and so on. Then problem solving to provide simple to complex solutions. Network drivers. Now a network driver is a program which can control the setup which connects your device to the internet. Okay, I'm just telling for your information. Now modern programs you can implement using C language also. Databases, large records of data can be stored. Language interpreters, different utilities or usages, and for software development. So you can keep in mind any 2 or 3 applications. Next, programming paradigms. So there are different programming paradigms such as imperative or procedural. Then you have applicative or functional languages. Then logic or rule based, and object oriented programming also. You can have a programming paradigm. So I'll briefly discuss what is the difference between these paradigms. First is procedural. Example is C, COBOL, Fortran. Procedural means there are different procedures. You can understand procedure as a set of code which are logically related statements. We'll come to it. A set of code. Sequentially, these sets are executed. So it is statement oriented. Now, example C, COBOL, Fortran. COBOL, it is written in capital because it is an abbreviation. COBOL stands for Common Business Oriented Language. Fortran stands for Formula Translation. Now, applicative or functional languages. So here functional means it is mainly based on the mathematical rules and mathematical logic. Based on the conditions, you can perform certain actions, such as if so and so happens, then so and so should happen. Like apply the condition and then only the action. Lisp is an example. Someone wants to join. Lisp is an example. Lisp stands for list processing. Then logic or rule based, depending on certain logical statements, that is program logic. It is also called as declarative language. You can perform the actions. Like for if the logic is satisfied, only then the statement will be executed. Example is Prolog. Prolog stands for programming in logic. So our main focus for the entire course is procedural language because C comes under that. Finally, we have object oriented. Example is C++, Java, Python, Kotlin. Object oriented means the entire program is decomposed into a number of entities called as objects, and there are certain functions which can manipulate over the data of the objects. So this we will learn in C++ only because C does not support object oriented programming. So I hope this is clear. Next is, now we have seen that C is used for software development. But what actually is software? It is a set of programs consisting of instructions that can enable the computer to perform certain tasks by which we can find the solution of certain problem. So software is nothing but a set of programs. It works along with the hardware, and then you can form your computer. Now, software is more related to the logic compared to the physical elements. As I said, hardware deals with the physical elements. Software is more logic. It has more of logic in it. After that, we have the types of software. Now, there are different types, but mainly we will focus on system and application software. So system software and application software are different. Then we have programming. We'll see in the next slide what they mean. Programming software is usually used to develop certain programs. Then we have engineering specific or scientific software. for engineering applications like calculating the heat capacity or any other like measuring the temperature, or in any IoT system, we can use these engineering specific softwares. Then embedded software means what? You can use the software in any other device, like in your washing machines. If you put a certain software, it can operate automatically. There is less of human intervention. Then another example of embedded software is your car braking anti-lock system. Then artificial intelligence, for that you have special software. Lisp language can be used for artificial intelligence. This is just for your information. Now, difference between system and application software. Excuse me. Now, system software is a type of software which is the interface between application and the actual operating system. So system software is used to interact with your hardware. It can interface between the application and software and the operating software. On the other hand, this side where you can see my mouse pointer, application software runs as per the request of the user. Means only if we want to use that software, we can open it or run it. It runs on a platform provided by the system software. Means it needs the system software in order to run. If you don't have system software, your application software will not run. So application software is dependent on system software, whereas system software is independent. Next, we use point number 2. The general system software is developed in low-level languages. That's why we saw that C++ being a middle level between low and high level, we can use it for system programming. It is more compatible, and it is more compatible with the system hardware in order to interact with it. So system software can interact with the system hardware. Then, but application software is a high-level language. It is used to it is used for their development as they're developed with specific purpose. So there are different languages, high-level languages used for application software, but mostly low-level languages are used for system software. System software, low-level language, application, high-level language. Now, what is the usage of the software? System software is used to operate with the computer hardware, as I mentioned, whereas application software can perform a specific task as per the user's demand. System software operates on computer hardware. Now, for their installation, system software is installed when operating system is installed. Application software is installed as per the user requirement. So, examples of system software is your compiler, debugger, assembler, and all, which can interact with the hardware. Whereas application software, for example, is your Microsoft Word, your Chrome browser, Notepad, or any application which needs the application software. So they are installed according to user's requirements. If I don't want a particular software, I will not install it. Then user interaction. User interaction is available in the case of system software, but application software, it does not, it can interact with the user interface, but it is more in compared to the system software. So system software, mainly we do not interact much with it, means user cannot interact much with it, but with application software, the user interacts more. That dependency, as I mentioned, system software is independent, but application software needs the system software to run. So as I mentioned the examples, some examples of system softwares are compiler, assembler, debugger, driver, whereas for application examples are web browser, any media player, word processor, and so on. So basically you can keep in mind system software and application software. System software is used for interacting with hardware. Application has more user interactivity. System software, it can run independently. Application software needs the system software to run. And you can keep in mind the examples. So this is the diagrammatic representation that which is dependent on what? In the middle, the core of the diagram, you have the hardware, your CPU, disks, mouse, printer, and so on. Then above that, as a framework, you have your system software, where you have the operating system, different utilities. And above that, you can have your application software, like computer games, your spreadsheet, Excel, word processors, different records, databases, browsers, and other various apps, either some games or however. Then now we will discuss that why we need compilers and interpreters. So basically there are three levels of programming. One is machine level programming language, second is assembly level programming language, and third is high level programming language. So machine level language is purely in the forms of ones and zeros, that is binary. You might have studied in your basic electronics engineering course that machine level, the computer understands only in binary format, that is zeros and ones. So in electronics, usually in the general case, suppose we provide the voltage, then it is denoted by high or true or one. If you provide the low voltage, it is denoted by zero or false or low. So one means indicates the presence of the voltage, zero indicates the absence of the voltage. So accordingly, when we program, whatever program we write, it is so whatever program we write, it is in the form of high level. So in order, the computer cannot understand high level languages. High level languages have the English statements, the syntax, and the proper meaning in them, which is easy for us to program in. So whatever we write, like take the input from the user, print the following statement, all that is in simple English language. It has certain syntax that has to be converted into zeros and ones so that the computer can understand. Otherwise, simply if we write in English statements, the computer will not understand and will not get the desired output. So once we compile, once we write our program, that needs to be converted into zeros and ones, and then the computer can understand it. So in order to convert the high level language to machine level language, we need interpreter or compiler. Depending on the programming language, they will either use interpreter or compiler. Python uses interpreter and C++ uses compiler. So what will the compiler do? It will convert your high level language code into machine level language. Now in between you can see assembly level language. Now this is just for your information. Assembly level languages is used to program your microprocessors. So if you want to perform certain action using your microprocessor, you will have to use the assembly level instructions. Now the assembly level instructions can deal with the registers, the stack pointer, instruction pointer, all that is out of the scope of this course, but I'm just telling you. So you can either add the data, multiply the data, or move the data from one place to another place. So all that can be done by the microprocessors, and you can actually program it. Now even assembly level language, the computer cannot understand. So what happens is that also needs to be converted into machine level language. Now how to convert the assembly level language to machine level language? Using the assembler. Now assembler is another system software, just like compiler and interpreter. So your assembly level language will be converted to zeros and ones using assembler. High level language will be converted to zeros and ones using interpreter or compiler. So I hope you understood why we need interpreter, compiler, and assembler.
Yes, sir.
Yes, yes, sir.
Yes, sir.
Okay.
Yes.
Yes,
Okay.
sir.
Okay. Yeah. Now, next is the difference between interpreter and compiler. If at any point you're not understanding or you want me to repeat, please unmute yourself and ask me to repeat, because here I cannot see the chat box because I'm presenting my screen. And if you are not understanding, just intimate me. Now, okay. Now interpreter and compiler, there are some differences between them. So look at the first column, interpreter. It translates just one statement of the program at a time into machine code. Means suppose you write one statement, means then you write another statement, and like this you will build your program. Once your program is coded completely, you will try to interpret it, and after it is interpreted, you will execute it. So when it is interpreting, this can be used to debug your program. Debug means if there are any errors in your program, the interpreter will highlight it. If there are any errors in your program will not run. So in order to detect the errors, you can use interpreter or compiler. And once the errors are detected, you have to remove or eliminate those errors. How you will do it? It is called as debugging. Bug or bugs means errors in your program code. So you have to debug your program. Once there are no errors in your program, you can successfully execute your program. And these errors may be of different types. We will see in our upcoming sessions. There is one topic of error handling exclusively devoted for this concept only, how you can handle your errors and avoid them to occur in your program, so that your software will be efficient. So getting back to the topic, interpreter will translate line by line. So suppose you have written your program code. At the fifth line, you have an error. So first to fourth line, everything is okay. There is no error. So first line will be interpreted. It will be, it's fine. There will be no error. Second line will be interpreted. Third will be interpreted. Fourth will be interpreted. Till now, no error. Soon as the fifth line is under the process of interpreting, there will be an error. So that line will not get executed and your program will not be interpreted further. Soon as error is detected, your program will not be interpreted further. Everything will stop. Then you have to debug your program and then again interpret it. Whereas in compiler, first point to the compiler side, compiler can scan the entire program and it translates the whole program into machine code at a time. Means, suppose there are 10 lines of code in your program, what your compiler will do, the entire program, it will try to find if there is any error and it will get compiled. And at the end, after all the lines have been inspected, if there is any error, at whichever line the error is, that will be highlighted as an error message. So suppose there are 10 lines of code, you have an error at line 1, line 5, line 10. So at these particular lines, there are errors. Let this one message you will get by the compiler. So the entire program is inspected and then the errors messages are given to you. Whereas in interpreter, line by line, the error is detected and soon as an error is found, it will give you the message and further no interpretation will be done. Is this point clear?
Yes.
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 Okay. Yeah.
Yes,
So
sir.
second point, yes, an interpreter takes less time to analyze the source code. Source code is nothing but your program code, which you have written. However, the overall time to execute the process is much slower. Means it takes less time to interpret the code, but the overall time that it takes to execute, it is much slower compared to compiler. Whereas second point under compiler, compiler takes a lot more time to analyze the source code. 1 second. So we have seen the first point. Second point, we are seeing an interpreter. It takes less time to analyze the source code, but overall execution time is much slower. Compiler point aside, second point, a compiler takes a lot more time to analyze the source code, but overall time is much faster. Third difference, third point, interpreter side, an interpreter does not generate intermediary code. Hence, the interpreter is highly efficient in terms of memory. Now, what is intermediate code? Means when it is interpreting, it is not generating any other side code or any other code. Whereas in compiler, it generates an intermediate code. This intermediate code is called as bytecode. Means your high level language, while it is getting compiled, certain other code also called as bytecode, the compiler generates, and then your program will get converted to machine language zeros and ones. Whereas interpreter does not generate such intermediate code, compiler generates the intermediate code. This is the third point. Now we are seeing the fourth point. Interpreter keeps translating the program continuously till the first error is encountered. As I mentioned, if the error is spotted, then it stops working and debugging will become easier, right? Because you know that here my error is, so I should not continue executing my program. First, I should deal with this error, then I can come back. Then compiler, it generates the entire error message wherever it is occurring the error. And then it becomes little difficult because maybe because the error is on first line, so you're getting so you're getting an error at the fifth line. maybe an error is at the 5th line, so you're getting an error at the 7th line. So it becomes difficult to debug. Whereas an interpreter, wherever the first error comes, you can easily deal with it, and maybe then after that you won't get any other errors. Then last point, example of interpreter. It can be used with programming languages like Ruby, Python. Compilers can be used with languages like C, C++. So basic differences are interpreter, line by line, it analyzes the program, whereas compiler, the entire program it will analyze and give you the errors finally. Then it generates intermediate code. Compiler does it, but interpreter does not generate intermediate code. So debugging is easier in interpreter, debugging is difficult in compiler. Now interpreters are used by programming languages like Ruby, Python, but compilers for C, C++. Now, I've explained you why we need interpreter and compiler. Can anyone unmute themselves or put it in the chat box? Why do we need interpreter or compiler? From what to what is the conversion? Can anyone tell?
Interpreter,
High level language.
interpreter
Sir, it translates the language for computer
high level
Okay.
language to the machine level language.
Yes, correct.
to make
Okay.
the computer understand.
Yes. And Python uses interpreter or compiler?
Interpreter.
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 Yes.
Interpreter.
And C, C++ uses compiler or interpreter?
Compiler.
Compiler.
Compiler. Compiler.
Okay. And assembly language, can you, is it easier to program or is it easier to program in high level language?
Sir, program in high language.
High level language.
Yes, correct.
High level language.
Okay. And C language is a middle level
Middle
language.
language.
Middle level.
Middle level.
Good, you all are understanding the concepts fast. So accordingly, I can decide at what speed I should go. Now, the next part. Now you have seen these program design tools in your unit 1 of programming and problem solving course in your first year of engineering. So basically you have algorithm, flowchart, pseudocode. So you can use an algorithm, flowchart and pseudocode in order to design your program. These will help you to design the code, and you can easily convert your algorithm or flowchart or pseudocode into a program which can be executed on the computer. Algorithm, flowchart, pseudocode cannot be directly executed on your computer. So what is the difference between these three is, the algorithm, it is a step-by-step procedure consisting of finite number of steps used to find the solution of a particular problem. So step by step, you can write the procedure and it should be finite. So you have seen the characteristics, right, of an algorithm: input, output, finiteness, definiteness, and effectiveness. So input means it can accept either 0 or no input, your algorithm or program. Output means the algorithm should generate at least one output. See, you're writing an algorithm to form a program, and a program should give particular output. Otherwise, there's no point in designing a program. Input, either it may be necessary or not. If there's no input, so it depends on your application. We'll see such programs. That is fine. Either 0 or 1 input, or other inputs you can have, but output, at least 1 you need. The next, finiteness. The algorithm should terminate after a finite number of steps. It should not be infinite ideally. Then definiteness means there should not be any confusion in the logic of the algorithm or the steps. There should not be any ambiguity. Then next is effectiveness, means it should be efficient, effective. It should give you the proper solution to your program, and you should be able to write an algorithm on pen and paper, using pen and paper. Now, the basic logic or how you will form an algorithm, it depends on your steps of problem solving that you have studied in programming and problem solving unit number 1. So the first step is to identify a problem. Then second is to understand a problem. Can you tell me which is the next step after understanding the problem?
Identify the list of alternative solutions.
Yes, correct. Very good. And after you identify the list of alternative solutions, what you will do?
Select the best way to solve the
Way to
problem.
solve.
Yes, correct. And after that?
Write down the procedure.
Instructions.
Yes. And finally, you will evaluate your solution.
Evaluation.
Okay. Am I right?
Yes, sir.
Yes.
Okay. Okay. Yes. So we have understood algorithm. Now flowchart. What is flowchart is, it is the graphical or diagrammatic representation of algorithm. Means the steps of an algorithm can be depicted by a diagram. There are certain symbols, you have already learned them. Then pseudocode. It is a combination of the simple English languages or statements and some common programming syntax. So you might have studied if-else statement. So it is a conditional statement. So you can write it in an algorithm like, if A is greater than B, then perform so and so. So such basic syntax you can write in a pseudocode. Then it is a combination of English statements as well as your basic syntax. So you have already seen examples of algorithm, flowchart, and pseudocode. Since to save time and teach more of the concepts, I'm not showing you the examples. But if you want, then in the next session I can show you. Now, next topic is, I have already explained on Sunday, that is difference between C and Python. We'll quickly go through it. So C is mainly used for your hardware related applications, whereas Python is used for general purpose programming. C follows imperative or procedural programming model or paradigm, whereas Python will follow object oriented programming. Then C, you have pointers concept, whereas Python there are no pointers. Even in Java, you don't have pointers. C uses compiler, Python uses interpreter. Then the code execution is faster compared to Python. If you're writing in C language, the code execution, it will take less time compared to Python. In Python, more time will be taken. Why? Because there is certain garbage collection also. We'll see that in our upcoming sessions, what is garbage collection. And last point, C is compulsory. It is compulsory to declare the variable type in C. Like you have studied different types of data types like integer, float, double, boolean, string, character. So these are the data types, and this type must be specified before you declare or initialize a variable in C language. For example, you have to write int a equal to 5, or you can write it in one statement as int a equal to 5. So in our next sessions, we'll be discussing all this in detail. Whereas in Python, you can directly write a equal to 5. Python will implicitly or automatically understand that a is storing a value which is of the type integer. Are these points clear?
Yes.
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 Okay. Now, this is an important concept, the basic structure of a C program. So there is a basic structure that all the C programs follow, and they should follow. So the first section is the documentation. Documentation means it's like you're creating a user manual or a user guide to your program. Whenever you develop a software, you have to, it is for your user. The user will use the software that you develop for him or her. So the user should know how to use that software. The user interface, the user experience all counts to the customer satisfaction. So the user should know actually how the software is running. And to write the software, you're writing programs. In the programs, you're using certain logic. So now you have to prepare certain documentation, certain guide you have to create, certain instructions you must write in your manual that if you want to do this, then please click on this button or whatever it may be. Then in the documentation, you should also include the name of the person who has developed the software or the program. Then what is the objective of developing the program? Why he has developed this program? Or what is the outcome of this program? What problems can you solve using this program? And so on. So I have written what is meant by documentation here in the next slide with an example. Documentation section is the part of the program where the programmer gives the details associated with the program. He usually gives the name of the program, details of the author, other details like time of coding or when it was created, certain description, so that anyone who is reading the code will easily understand it. Next, what we have is the example of documentation section. So this is a basic example. You can include other details also, such as what is the file name or program name. So the first program which you have solved in Python, it may be hello world only. It is a basic program where you have to just print the statement hello world at the output, at the console window. So the file name here is hello world.c. .c means the file contains a C program.
C program.
Yes. So .c is the extension for the programs which are written in C language. The file name should always terminate with the extension .c. If it is C++ program, it will be .cpp. If it is Python program, what will be the extension?
.py.
Yes, very good. Yeah, correct. So the author's name also you can give whoever has developed it, the date of manufacturing the software or program, then the description. See here, since this is a basic program, they've written only little. What they've written is a program to display hello world. And see here, this is an example of a program. You don't need any input. I was discussing when we were discussing algorithm, that algorithm, either it may take an input or it may not take an input. For a hello world program, you don't need an input because you have to just print a statement, a string. So this is an example of documentation section. Below the documentation, you have the linking section. Now linking means, I've explained it in the next slide. Link means the part of code is used to declare all the header files. Means whatever you write in the link section, it is used to declare all the header files. Now in C, you usually don't have header files. Only what you can do is you can import certain libraries and their utilities. But for C or C++ program, you have to include certain header files. Now, how can you include these header files is by writing, see your example, hash include within angular brackets, what you have to write, stdio.h. Means when you write this piece of code or this line, it will indicate that you are using this library in your program. So this part of code is used to declare all the header files that will be used in your program. If you don't declare this linking section, whatever further you write, it will not execute properly. You will get errors. Now this leads to the compiler being told to link the header files to the system libraries. stdio.h extension means it is a header file. So this header file, it needs to be linked with the system libraries so that you can use whatever is defined in the library. Like in the library, your printf, scanf, CNC means for C language it is printf, scanf. For C++ it is CNCout to accept and display. So that you can do by stdio stands for standard input output. So for that you have to include this library. Then suppose you're using getch in your program. We'll see the examples of all this, but for now I'm just introducing you. If you write getch, if you want to clear your screen, you use CLR SCR, clear screen. All this is included in one more library that is called conio.h, console input output. So we'll see all this in detail. For now, I'm just informing you that how the header files can be. Then there is another header file like math.h. So what can you use? What can you do using this header file? You can find the absolute value.
Arithmetical
Yes,
functions.
arithmetical functions, absolute value, square root of a number you can find out. Then power of a number you can find. In Python, use which function to find the power of a number? Do you know it? Okay, no problem. You use no. You use POW. You can that is that function you have to use. Then for square root you can use SQRT. Then for absolute you have to use ABS. So there are many such examples. So we'll study the math library also in the third unit. So we have seen the documentation linking section. Then we have the definition section. Now definition means you can define certain. Yes, ma'am.
Right now, as you're telling that there are header files in C, we are including because standard library has been there in that header files. Yes or no?
Yes,
Ponyo.h,
ma'am.
studio.h, math.h. Similarly, now students who are there yet right now here, you are studying Python. Is there any standard library that we are including in the Python? This question is for all students. Is there any
Yes, ma'am.
is there any standard library that we are including while doing the program in the Python?
No, ma'am.
There
Oh,
are
ma'am.
modules.
And there are functions like math,
At the start, we
math
have to do
socket.
import.
Ma'am, there are
Yes.
no
There are
header
different
files, but
modules.
we are
There are script
using.
modules, ma'am.
Yes.
On the
Right now, your printf, scanf also need the library that's nothing but studio.h. But here in Python, printf, scanf is not there. What we write down to display it directly, print.
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 Direct
Print.
print is there, and
Print.
there no need of any standard library file. But here in C, it is there.
Yes, ma'am. Yes, ma'am. Okay.
Okay, Joel, you can give the correct answer here and continue.
Yes, ma'am. So we have seen the documentation section, then the link section, now definition section. So what is in the definition section is you can define certain constants or certain functions also. We can define like what value. This is actually called as macros definition. We will see this in the further unit. But for now, you can understand that we are defining so that we can define certain constants. Now a constant is a variable whose value will not change throughout your program. So like the constant pi, the pi value is 3.14, or if you want, you can give 3.1415 or how many ever digits after the decimal point you can give. So whenever you use the variable name pi, always the value 3.14 only will come because pi is a constant. So this way you can define your constants and use them in your program. Then there are other constants like speed of light, speed of velocity, or whatever, however your program requires, whichever constants, you can use them. So you have to, how you have to do it? Hash define the name of the variable, and you can write 3.14. Now we have seen the definition part. So first, documentation. Documentation is not a part of the program. It is just a guide. Then you have your linking section. There you have to mention the header files. Then definition section can define certain constants and other things also. Then is the global declaration section. So for now, you can understand the global declaration as the variables whose value can be accessed throughout the program. We know that in C, we can write different functions, different procedures. So if you define any variable within a certain procedure, you cannot access it in other procedures or functions. But if the variable is defined as a global variable, then that particular variable can be used in all the functions. Suppose you write a equal to 5, then you define all your procedures. Then within the procedure, if you're changing the value of a, then it will affect the value of a in the other procedures also. Whereas if there is a variable in procedure 1, you're changing its value, you cannot access that same variable in procedure 2. So global variables are those which are accessible throughout the program, whereas local variables are those which are defined within a particular scope or within a particular block of code. Scope is nothing but a region in which you're writing your code. So that is the difference between global and local. That also we are going to see in our further sessions. Then finally, after that, you have your main section.
Joel.
Yes,
In
ma'am.
chat box, some questions are there for you.
Okay.
That hash is a comment or what?
No. In Python, hash is a comment.
Mm.
In Python, when you use hash and you write anything after hash on a single line, that is a single line comment. Now, if you want to give multi-comment in Python, what you do, you use triple quotation marks. Correct? So hash in Python is single line comment. But in C, C++, hash is used for the macros definition, or if you want to include the header files. Is your doubt clear, Pranay?
Yes.
Okay. Then but hash include and hash comments are different. Yes, hash include is for C++. Hash you can give any other comments, but in Python. So it will be exactly executed. Okay, then we'll continue. So main function, now in Python, you can either use a main function, or even if you don't use it, it's all right. But in C++, you have to use the main function. Now main function, it is the function from where the execution of your program will start. Means you have written many procedures, many functions. Those functions, you will call them in your main function. So whichever function or procedure is called first, that should be written first in the main function. So procedure 1, I'm calling first, then I'm calling procedure 2, then I'm calling procedure 3. So you can either call function in main function, or other processing also you can do in main function. But your program has to include only one main function. You cannot have more than one main function. Only a single main function from which the execution of your program will start. Now, if you are not using functions, all the code that you write in your function, that you will have to write in your main function. So as per the community guidelines and as per the standards, it is always better to call your function. There is another advantage that once you write your function, you can call it again and again, how many ever number of times you want. So if you don't use a function, you'll have to write those lines of code again and again. So if you use a function, your code is reusable. That is another major advantage. So in main function, what I've written, every C program needs to have the main function. Each main function contains two parts. What are the two parts? One is declaration and one is execution. So in the main function, you have to declare certain variables, or variables like int a. Then afterwards, you can initialize if you want. So some declaration is there. Then the execution part. Now the execution part is usually within curly brackets or curly braces or flower brackets, and it ends with a closed curly bracket. Once you start a curly bracket, you have to close it after you finish that particular block of code. Otherwise, you'll get an error. Both declaration and execution part are inside curly braces. Okay, this is an example, int main. In bracket, that is called parenthesis, you can write void, means it is not taking any arguments. Even if you don't write void, it is fine in C++. Then there is a declaration and initialization done simultaneously here. Int a equal to 10. Then you have your printf statement. Why you use printf is because printf is used to display the particular value on your output, at your output. Then return 0. Now it depends on your compiler whether you have to return a value or not. So we'll see all that. After main function, you have your subprogram, which can be any function like int add. Then you can return the value or whatever. So this is an example. Hash include, which is the link section. Documentation is not a part of program. Link section, hash include. Then hash define for constant macro definition. Then this is global declaration, int a. Then certain functions you can write. And then your main function, where I have called that function. What is the name of the function? Function. Here, what is the name of the function? Function. So I'm calling that. You need to pass actually some values over here. Why? Because it has certain arguments. You have to pass some values. Then other statements also you can have in your main function. So since we're running out of time, this was the last topic. So is there any doubt or question you want to ask me?
Can you please explain about voids that you told, like the arguments?
We will see that in our functions topic. Arguments means when you call your function, you have to pass certain values like 2, 3.4. So 2 will be assigned to x over here.
Okay.
And 3.4 will be assigned to y, which is a float type. So I'm giving decimal number. So 2 will be stored in x, 3.4 will be stored in y. And then within this function, you can deal or manipulate these values. Okay. And then you can return it also. Okay. We'll see all this in detail. Don't worry. This is just, I wanted to explain the structure of a program. So I have given it.
Yes, sir.
Any other doubts, sir? Yes, welcome. Any other doubts or questions?
We will be learning C++ also, or only C?
For now, we are learning C language. Once we finish learning C language completely in this course, we may study C++ also.
Okay.
Okay. Any other doubt or suggestion or question?
So what is library system?
System libraries means in those libraries you have defined it is already defined. The compiler already knows how to access it. There are already certain definitions in the system libraries, and those definitions you can access in your program. Means whatever is written in those libraries, you can access in your program. You can, like, suppose printf is also a function, scanf is also a function. You are just calling those functions in your program. You're not defining what should be done when you're calling for printf. These definitions are already available in the library. You have to just call the function, and its definition is available in the library. Only you have to call, you have to not define. So in the library, the definitions are present. Different constants are also defined in the library. Okay. Any other question?
For C programming, can we use Turbo C++ because it has been already installed in my PC?
Okay, you can use Turbo C++, but there are certain differences between the Dev C++ compiler and Turbo C++. But I'll tell you, in the next session, we will start our programming. I'll tell you the differences and how to go about with it. Is it okay?
Okay.
Okay. Any other question? Okay, so I'll be sharing this PPT later on. You can revise it if you want. Now we'll have the quiz. Okay, so there are 6 MCQ questions. Each question has maximum 4 options, A, B, C, D. You have to now for this time, since I have to keep a record of your score in the quiz, I have designed a Google form, and you have to attempt the quiz using that Google form. I'll be putting this link in the chat box, and within 4 minutes from now, you have to answer it. There are just 6 basic questions from whatever I've taught today. You can answer it quickly, and your score will be displayed immediately after you submit your quiz. Only once you can attempt the quiz, and after you submit it, I'll be displaying your score also on the screen. Is it okay? Shall we start?
Yes.
Yes.
Okay. Yeah. Just a minute. So I've put the link in the chat box. Just click on that link and start answering your quiz. There are just 6 questions. And suppose you are not attending the quiz and you're just leaving the meeting. So before leaving, no, you have to put your attendance here. Like, for example, if your roll number is, you have to write your roll number, then your name and your division. After attempting the quiz,
Joel.
yeah.
I have sent this attendance link. I'll forward it to you.
No, actually, because I'm recording this meeting, no, so for that I need actually the attendance. Okay, they can fill the attendance form later on, but for now, after your quiz, you have to write your attendance here also. Because the messages that you put in chat box are recorded, so I have to maintain that. So I'm telling you. First, you attempt your quiz. If you're not attempting the quiz or you don't want to attempt, then you can put your attendance and leave if you want. But I suggest you should attempt the quiz. So don't leave without the session is concluded.
Yeah, sir, done. I have attended the quiz.
Okay, you can wait because after 4 minutes, I'm going to display the result, like who has scored the maximum and all. So
Okay.
till then, you can put your attendance in the chat box. Whoever finishes attempting the quiz, put your attendance, roll number, name, and division. For example, 1302, your name, FEC or FEA, whatever your division is. Another 2 minutes and then I'll stop accepting the responses. So there are 31 participants till now. Only 11 have answered. So okay, last 30 seconds remaining. After that, I'm closing the response, accepting. So I've stopped accepting the responses. Let's see who has scored the highest. So I can see Ruchi Patil, 10 out of 10. Then Pratik Gupta, again 10. Okay, so today the highest score is Ruchi and Pratik. Then some have scored 9 also, Alisha and Yashraj. Then Ankit, Anushka. Some have scored 8, 7. Okay, your score is quite impressive. So all this will contribute to your final score at the end of this course. So I finished for today's session. Ma'am, if you want to say something.
Sir, I couldn't submit my form.
You might have submitted it after I've closed the response. Okay, I'll
Excuse me, sir.
open the accepting the responses, but after this session. If you want, you can just try attempting that quiz, okay?
Excuse me, Dada, you are sharing the PDF and that link, no, for
Yes, I will share everything. I'll share
app.
PPT and everything. Yes.
Okay, thank you.
Yeah. Ma'am, if you want to say something.
So, guys, have you enjoyed today's session?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Is he going fast, slow, anything? Let him know so that he can make the adjustment accordingly.
Ma'am, the
Speed
slides were
is
too
perfect.
fast.
One at a time. Pratik.
Ma'am, the slides were moving too fast, as I saw.
As I'll let you know that as little bit theoretical was there, so he was running fast, and the thing whatever he has prepared, his mindset was there that he want to complete within the stipulated time whichever has been given. So because of that, I think so he was little bit fast. Is I'm right,
Yes,
Joel?
yes, ma'am. And don't worry, I'll be sharing all these PPTs. You can go through at home also after this session.
One more thing that I want to tell you that right now we are doing the Python, simultaneously Python and C. Most of the things are similar and some are different. Now syntax will be different and meaning will be same. Meaning will be same, but the syntax are different. Just concentrate. Now, if he start teaching you data types and all that things, you know data types, everyone. So if he goes little bit fast also, it should be self-learner that you have to do. Yeah, he will means even I'll request Joel that instead of much more slide, make it practical oriented also.
Yes, ma'am. From next session, everything is practical only.
Okay. Anything that anyone want to say?
Overall was all best.
Okay, good, Joel. It was nice one.
Thank you, ma'am.
But it has been observed, Man, coordinator Man.
Yes, ma'am. Yes, ma'am.
It is observed that today attendance was less.
Yes, ma'am. I don't know, ma'am, how. I'm only 6 to 7. I think 6 to 7 were absent.
No, 28, 9, something present. Okay, you may have the attendance.
Yes, ma'am.
You can
34
go.
were present and
Okay. So total we are having 40.
yes, ma'am. 43, 42,
Yes.
40.
Okay, that we can. Yeah, we have to work out on
Yes,
that
ma'am.
also. Okay. Chalo, Joel, then thank you. We can
Yes, ma'am.
end if nothing is there.
Yes, ma'am. Okay, I'll stop recording this session and then I'll share all the resource materials to you. Has everyone put their attendance in the chat box?
Yes.
Yes, sir.
Yes.
Okay.
Bye. Good night.
Bye.
Bye. Good night.
Okay, thank you.